per CAP theorem, we cannot have both consistency and availability in the system.
No.
There were issues with the centralized design that were there in terms of availability that led to the invention of distributed systems. Hi, welcome to Design Strong. In this video today, we will discuss about the most important CAP theorem. In order to understand CAP theorem better, first try to understand that why we went from a centralized system to scalable distributed systems. With centralized systems, there were problems such as availability and single point of failure, which led the computer engineers believe that there could be another sort of design that can help us serve the purpose of availability and consistency. That's when the distributed systems came into picture. And just to understand the sort of possibilities and limitations that a large scale system can have, we will try to understand today the CAP theorem. So CAP theorem basically stands for consistency, availability and partition tolerance. We need to understand this with one of the examples. Let's consider a situation. You are starting a startup which is into tech domain, and you start with, let's say, providing users with some sort of a custom ATM functionality which allows user to, let's say, add balance, update balance, and maybe just check out the balance that they have in their account using it, let's say, NFC chip or NFC sort of device, which is like most trending these days. Because you were a startup, you started with 2 stores wherein you can go with your NFC device, just tap out the NFC device or keep it in the vicinity and then do the operations. Now, with time, your business went well and the number of requests, the number of users who were using your service also increased, and you decided to scale. So, when you said you decided to scale, in terms of scale, you started to have another ATM or store. So, now you have 2 ATMs or stores which are serving to all the 3 requirements that the user have, which is, let's say, withdraw balance, add balance or check balance. Now these 2 ATMs are connected with each other using a network. If everything in the system is going fine, network is also perfect, then this system will work perfectly. ATM A and ATM B will both be connected and will both be serving the same sort of request. For example, if let's say user A checks their balance on ATM A and let's say the balance is 150, after some time the same user checks the balance of another ATM B, the balance is again 150. So systems are in consistent state. Another example, let's say if user withdraws 50 rupees from ATM A and then checks balance on ATM B, the balance gets updated from 150 to 100. Still the systems are in consistent state. Another example is, let's say if user decided to deposit some money, they decided to add another 100 bucks. So they added 100 bucks from, let's say, ATM B this time, and on ATM A the balance check retrieved 200. System is working perfectly fine. Earlier, let's say one ATM was able to serve 100 users. Now 2 ATMs together, let's say, can serve to 200 users. So scaling is working fine. You went ahead to introduce a third ATM as and when the scale demanded. So your system and your business is working well, but there comes the scenario, there comes the limitation. What if something goes wrong between the connectivity between, let's say, ATM A and B in our previous example?
वक्त बदल दिया, जज्बात बदल दिए, जिंदगी बदल दी.
Now, when some sort of fault happens between A and B, this is when we can say that there has been a partition being created between A and B. Agreed? So let's say if A and B were connected via network, then if this network goes down, we say that there is a partition being created because A and B now may or may not be in sync. Now let's say if at this point of time user A checks balance on ATM A, let's say the balance is 100. If the same user withdraws balance on ATM B for 50 bucks, the balance on B is 50, but the balance on A is still 100. At this point of time, we can say that our system is not in consistent state. Similarly, let's say in case of a fault, if we decided not to let user perform this operation of withdrawing, adding balance or even checking balance for that matter, or let's say we just do not allow user to add or withdraw money and just check the balance. Still, the systems after partition will be in consistent state. But is it available? Are all the features available? No. In this case, we cannot add or withdraw money. So this is availability. So as per CAP theorem, we cannot have both consistency and availability in the system if the system is partitioned or if the system is working on a large scale in a distributed architecture. So this single statement is good enough to understand what is CAP theorem. While CAP theorem says that consistency and availability both cannot be achieved in case of partition, there are concepts which allows us to have up to 99.9% sort of availability into the system with consistency. How can that happen?
मारो मुझे मारो मारो मुझे मारो मारो नहीं ये मजाक.
Let's consider the example again. So let's say if there is a network fault between the two ATMs that we have. What if we have multiple networks? What if we have network A, which is primary network, and then we have B and C, which is like a backup network which can be used if, let's say, A goes down. In that case, possibility of a fault goes down. So this is how it works in large scale systems as well. Let's say if we have to consider an example of a distributed database for that matter. Let's say if there are reader-writer which are working. So let's say if there are reader and writer, there is one writer which is the write DB where all the writes happen, and then there are multiple readers which are serving to the read request. Now consistency between these write and reader are perfectly fine in case the network is fine, in case there is no fault in the system. Whereas in case if there is a fault, in that case the system's consistency can get affected. So what we do, let's say in this case what we really do is, if reader A has a network issue or it is not able to get a heartbeat from the writer or get an update from the writer, in that case we just simply remove this reader out and work on basis of reader B and C, and in the meanwhile we try to get another reader into the scheme, so that availability is also not compromised and consistency is also there. So while CAP theorem says that in case of partition we cannot have both, it's not like in 100% that will be the case, but yes, as the concept says, we need to understand that whether our system should focus on consistency more than availability or availability more than consistency. I hope this clarifies your doubts in simplicity about the CAP theorem, which is one of the important topics for system design. In case if you like the video, hit the subscribe button and stay updated with the upcoming videos, and say design strong.